Hello viewers on YouTube. In this video tutorial, we are going to consider the symmetric properties of roots. If you could recall that if alpha and beta are the roots of a particular quadratic equation, let's say we are considering a standard form of quadratic equation. So we have ax squared plus bx plus c equals 0. Now there's a proof that shows that the sum of these roots, which is alpha and beta, alpha plus beta, is equal to minus b over a. Now you notice that a, b, and c are the constants that are present in that quadratic equation, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant term, or the term that stands alone. Okay, now the proof also shows that the product of the roots alpha beta is equal to c over a, and these results can be used to determine some other relations involving alpha and beta, even if alpha and beta are not known distinctly. However, these relations are said to be symmetric in nature. They are said to be symmetric in the sense that regardless of how they are relating alpha and beta, if the position or if alpha and beta are interchanged, the results they will provide will remain unchanged, or the result will be such that it's being multiplied by -1. I'm going to show you what I'm saying makes sense. But to put this into good use, let's try to consider some examples. And along the way, we will make sure we show that these relations are symmetric in nature. So let's consider a particular quadratic equation. So let's consider 3x squared minus 4x minus 1 equals 0. If you consider this quadratic equation, how can we find the sum of the root alpha plus beta? What would it be equals to? First, to determine if this relation is symmetric, all we need to do is to interchange the position of alpha and beta. Now tell me, if beta tends to now be here and alpha tends to be here, would the result be different? Is alpha plus beta equals to beta plus alpha? Well, in algebra, we know that this is absolutely correct. Alpha plus beta is equal to beta plus alpha. So therefore, we can say that this relation is symmetric. And if that is the case, we can find its value. Now, earlier we said that there's a proof that shows us that alpha plus beta is simply the ratio of the coefficient of x, then divided by or to that of coefficient of x squared. However, it has to be multiplied by a negative sign. So this will be minus multiplied by -4 over 3. Don't forget, the formula is such that alpha plus beta is equal to negative b over a. Now keep in mind, a is the coefficient of the leading term, that's x squared. So a is 3, b is -4, and c is -1. So if we plug in this into the formula, we will end up having something like this. And if we simplify that, then we should have 4 over 3 as our b, or as our alpha plus beta. And that's it. Now let's consider another example. What about alpha beta? How can we find its value? First, let's know if alpha beta are symmetric. Alpha beta is absolutely the same as beta alpha. Interchanging the position doesn't alter the results. So therefore, we now have alpha beta from the formula we said that's equal to c over a. C in this case is -1 and a is simply 3. So therefore, alpha beta would be equals to -1 over 3. That is the solution to this problem. Now, let's try to consider using alpha plus beta and alpha beta to solve some other symmetric relations. So let's consider the first one. How can we find the value of alpha squared plus beta squared? Feel free to pause the video and figure this out yourself. So what I would like to do is that I would like to just write down the value of these two somewhere without getting rid of it. So let's put it in here. Alpha plus beta equals 4/3, and alpha beta equals -1/3. So these are what we'll be referencing to as we proceed forward. Now we can get rid of all this. Even in fact, we can get rid of this as well. So the goal is to find alpha squared plus beta squared. Whenever you are to simplify something like this, think of expanding alpha plus beta or squared. Now in our algebra, to expand alpha plus beta or squared, we notice that what it means makes sense is that alpha plus beta is multiplying itself 2 times. Now to expand this, all we need to do is to distribute each term respectively. So alpha times alpha gives us alpha squared. Then plus alpha times beta gives us alpha beta. Then plus beta times alpha gives us alpha beta. Well, it's supposed to be beta alpha, but we actually chose it earlier that beta alpha is the same as alpha beta. So this is again beta times beta gives us plus beta squared. So now we can rearrange. These are like terms, they can be addable. So we have alpha squared. So instead, I would like to bring this first, plus beta squared. Then adding this up, we have plus 2 alpha beta. And don't forget, it still equals to alpha plus beta all squared. Now, the goal is to solve for this, which means I can actually bring this to the side or subtract 2 alpha beta from both sides. So left over for the value of alpha squared plus beta squared. Or in other words, if we isolate alpha squared plus beta squared, we now have alpha plus beta all squared to now be subtracted by 2 alpha beta. Now as you can see, we have actually manipulate alpha plus beta all squared to the extent that we can now use it to solve for alpha squared plus beta squared. Now these values and these values are known, we can substitute respectively. Alpha plus beta is 4/3. So we have 4/3 all squared. I hope you are getting what I'm trying to do. I just tried to substitute alpha plus beta right into this bracket, which is what we have right here. Good. So minus 2 alpha beta is -1/3. Multiplied by -1/3. And this is equal to, now 4/3 squared gives us 16/9. You know, when you square the 4, the square will affect everything within the parentheses. So squaring 4 gives us 16, squaring 3 gives us 9. Now when I multiply -2 by -1 gives us +2/3. So plus 2/3. Now LCM can be 9. You know, let's combine these two fractions. Now 9 in 9 gives us 1 times 16 gives us 16. Then we have the sign plus. 3 in 9 gives us 3 times 2 gives us 6. So 16 plus 6 gives us 32. So therefore, final answer is 32/9. If you want, you can leave your answer in mixed number. But this is alpha squared plus beta squared. And that is the solution to this problem. Well, I think there's a mistake here. 16 plus 6 should be 22 and not 32. Not bad. So this should be 22. Perfect. So that's it. Now let's consider another relation. What about 1/alpha plus 1/beta? Now these are just some likely relations you can be required to find in terms of alpha plus beta and alpha beta. So what do you think we can do in order to manipulate 1/alpha plus 1/beta to the extent that we would be able to find its value by just substituting alpha, beta, and alpha plus beta, because that's what you have to be putting into account. So first, before we proceed forward, let's try to confirm if this relation is symmetric. So changing the position or switching the position of alpha beta, what will we have? Notice that will become 1 over beta plus 1 over alpha. Does this make sense? Notice that this is absolutely right. They are the same. So therefore, the relation is symmetric in nature. So how can we manipulate? Well, let's try to find the LCM. Solving this algebraic expression, because it consists of expressions. So solving this algebraic fraction, we can find the LCM. The LCM will be alpha beta. Alpha in alpha beta gives us beta. Beta times 1 gives us beta. Now the sign plus. Beta in alpha beta gives us alpha. Multiplied by the numerator 1, we still have alpha. Well, fortunately, we can now substitute what we have. Because beta plus alpha is absolutely alpha plus beta. Then divided by alpha beta. So we are good to go. So substituting alpha plus beta, which is 4 over 3, we have 4 over 3. Now instead of using this number line division, I would like to use a regular. Divided by alpha beta, we got that to be negative 1 over 3. This is 1, not 7, okay? Okay. Now, we can use the concept of keep, change, and flip. We keep the first fraction, we change the sign to product, times, then we flip this last fraction. So, flipping it in the sense that the denominator becomes numerator, and numerator becomes denominator. Now, notice that the 3 cancels, and 4 divided by negative 1 result in negative 4. And this is our final answer to 1 over alpha plus 1 over beta. And by now you should have been getting used to the logic of finding some other relation in terms of alpha plus beta and alpha beta. Let's consider more so you can develop your understanding to a higher level. Now, consider this relation. Alpha over beta plus beta. Oops, let me write that again. Beta over alpha. How can we find this relation in terms of alpha beta, or using alpha beta and alpha plus beta? Since it is algebraic expression or algebraic fraction, just like before, let's try to combine them. But is this relation, is this symmetric? What do you think? Well, let's try to flip the position. Wherever you see alpha, change it to beta. Wherever you see beta, change it to alpha, and see if they are the same. So let's assume they are equal. If they are not equal, then I'm going to cross it right now. But let's leave it aside first. So instead of alpha, we have beta. Instead of beta, we have alpha. Instead of beta, we have alpha. Instead of alpha, we have beta. Does this make sense? Are they the same? Study it. Well, to me, it's just as if we brought this entirely right here, and we brought this as well right here. So, since it is positive sign that is still connecting them, there won't be changes in the result they will provide. So, therefore, this is absolutely symmetric in nature. So, we can proceed forward on finding the LCM or combining the fraction. So, the LCM will still be alpha beta. Beta in alpha beta gives us alpha. Alpha times alpha gives us alpha squared. Perfect. Alpha in beta gives us, in alpha beta gives us beta. Beta times beta gives us beta squared. So we're close. Beta squared. Now, alpha beta, we got that already as a negative 1 over 3. But what about alpha squared plus beta squared? Earlier, we have provided the answer to that, so we can just bring it back. If you could recall properly, we said alpha squared plus beta squared is simply alpha plus beta all squared minus 2 alpha beta. So what I'm going to do right now is that I'm just going to replace this right here with this. And therefore, we now have alpha over beta plus beta over alpha to be equals to, I'm writing this, alpha plus beta all squared minus 2 alpha beta, then entirely divided by alpha beta. Okay, now we can substitute the corresponding values. Alpha plus beta is 4 over 3, So we have 4 over 3 all squared. Then minus 2 alpha beta. Alpha beta is negative 1 over 3. So minus 2 multiplied by negative 1 over 3. Then divided by alpha beta, that's it, negative 1 over 3. Okay. Now I can simplify this forward. However, you can make this more faster and easy for you. As soon as you have solved alpha squared plus beta squared, just put in the answer right here. You don't need to do all this steps. Okay. So we have 16 over 3, the minus, it becomes plus 2 over 3. Then I'm putting in the parentheses, divided by negative 1 over 3. Combining the expression within, or the values within the parentheses, we have, okay, let me write it here, 16, the LCM should be, okay, this should be 9. We are squaring the 3. Okay, take note of that. 3 squared is 9. Take note of that. So the LCM is 9. Earlier, let me just add 22. If you recall, we said we got 22. Then multiply by 3 over negative 1. So I've flipped this fraction, I've changed the sign. Okay. Now 3 here 1, 3 here 3. Final answer is simply negative 22 over 3. And this is a solution to alpha over beta plus beta over alpha. And that is the solution to this problem. Hopefully by now, you should have been developing your understanding in this concept. Let's consider example number 4. Consider this relation alpha cube plus beta cube. How can we find its value using alpha beta and alpha plus beta? So just like before, is this relation symmetric? Is alpha cube plus beta cube equals to beta cube plus alpha cube? Since it is addition that is connecting them, then this is absolutely true. If that is the case, to solve for alpha cube plus beta cube, think of expanding alpha plus beta all cube. In algebra, we know that alpha plus beta all cube means alpha plus beta is multiplying itself 3 times. However, when alpha beta plus beta is multiplying itself 2 times, we know that that is simply alpha plus beta all squared. But we have made the expansion of alpha plus beta all squared earlier, and we said that is equal to alpha squared plus 2 alpha beta plus beta squared. Then that is multiplied by alpha plus beta. Okay. Now at this point, we can expand this other expression by just distributing each term to these binomials respectively. Okay. So alpha squared times alpha, that gives us alpha cube. Alpha squared times beta, that gives us positive alpha squared beta. Positive 2 alpha beta times alpha gives us positive 2 alpha squared beta, and positive 2 times beta gives us positive 2 alpha beta squared. Beta squared times alpha gives us beta squared alpha, which you can call alpha beta squared. Then beta squared times beta gives us beta cube. Okay, now let's combine like terms. So we have alpha cube. So instead, I will write this one to follows plus beta cube. Now alpha squared beta is the same as 2 alpha squared beta. So therefore, they are addable, or can add them up. So we have plus 3 alpha squared beta. Similarly, 2 alpha beta squared is the same as 1 beta squared alpha. They are like terms, by the way. So they are addable. So we have 3 alpha beta squared. Now the goal is to isolate alpha cube plus beta cube. So these 2 terms can be taken to the side. Or we should subtract both sides by negative alpha squared beta and negative 3 alpha beta squared. So this should be 3 alpha squared beta. Okay. So we have the space. Let me get rid of this right now. So don't forget, it is alpha plus beta cube that is equal to all this. So therefore, if we bring this 2 to this side, we have alpha plus beta all cube minus 3 alpha beta, alpha squared beta, then minus 3 alpha beta squared equals alpha cube plus beta cube. Okay. Now at this point, let's factor out negative alpha beta here. So we have alpha plus beta all cube minus 3 alpha beta. Now what will be left here? That will be alpha. 3 alpha negative has come out. This to go, so that will be left over with alpha. Alpha. Now again here that will be beta. Well, the sign will be positive. When this expands this one back, it becomes this. So the sign will be positive. Good. So this will be equals to alpha cube plus beta cube. Now it's now in the form in which we can plug in these values respectively. So therefore, alpha plus beta, that's 4 over 3. We have 4 over 3 all cube minus 3. Alpha beta is negative 1 over 3. And again multiplied by alpha plus beta, that's 4 over 3. So simplifying this forward, we have 4 cube is 64, 3 cube is 27, and minus 3 times minus 1, that gives us plus 3 over 3. It cancels actually, and again multiplied by 4 over 3. So these cancels gone. So therefore, we're just left with alpha cube plus beta cube to be equals to 64 over 27, and the sign is plus 4 over 3. So this is just like 4 over 3 times 1, because this has become 1. 3 is cancels 3. So the LCM can be 27. So 27 is 1. We have 64 plus 3 in 27, that's 9. 9 times 4 is 36. So 64 plus 36 results in 100 over 27. Final answer. And that is the result to alpha cube plus beta cube. And that's it to the solution. Before I end this video, let's consider one last example problem. Consider alpha minus beta. How can we find it? Pause the video and apply everything we have discussed earlier and see if you get the answer right. First, is alpha minus beta, is it symmetric? What would you say? With changing the position of this relation, we have beta minus alpha. Does this make sense? Well, in algebra, these that we have at the right hand side is said not to be equal to what we have at the left hand side. But from our knowledge, right from the beginning of this video, we said that the relation that be in terms of alpha and beta are said to be symmetric in the sense that when alpha and beta are interchanged, the results remain unchanged, or the results multiplied by negative 1. Now, if I multiply this at the left hand side by negative 1, what would happen? In this, that you have minus 1 times alpha minus beta. Minus 1 times alpha gives me minus alpha, and minus 1 times minus beta gives me plus beta, which if I rearrange becomes beta minus alpha, which turns out to be the same as this. So if that is the case, this relation is symmetric. So please be very, very sensitive. They must not be equal all cases. Sometimes they might be multiplied by negative 1. So those are the two conditions you have to keep into account while testing or determining if the relation is symmetric or not. Thank you. So since they are symmetric, we can proceed on finding what it is. So what do you think, what algebraic manipulation can we do to find alpha minus beta. What I would suggest doing is that let's expand alpha minus beta all squared. Expanding alpha minus beta all squared means that will result in alpha minus beta multiplied by alpha minus beta. Which expanded alpha times alpha gives us alpha squared. Alpha times negative beta gives us negative alpha beta. Beta times negative beta times alpha, negative alpha beta, negative beta times negative beta gives us positive beta squared. Now if we rearrange this expression at the right hand side, we have alpha minus beta squared to be equal to alpha squared plus, so let me write plus beta squared first, plus beta squared minus 2 alpha beta. But earlier in our previous examples, we have been solving for alpha squared plus beta squared. If you could recall properly, we said alpha squared plus beta squared is simply equals to alpha plus beta all squared, then minus 2 alpha beta. If that is the case, can we just replace alpha plus beta all squared with this? Yes, we can. So therefore, we now have alpha minus beta all squared to be equals to alpha plus beta all squared minus 2 alpha beta. But this is still there. Minus 2 alpha beta. Now, since they are like terms, we can add them up. And eventually, we have alpha minus beta all squared to be equals to alpha plus beta all squared minus 4 alpha beta. As negative 2 gives us negative 4. Now, the goal is still to solve for alpha minus beta. Well, notice that what we now have at the right hand side is now in such a way that alpha beta and alpha plus beta can be substituted for it. Then why don't we just take the root of both sides in order to have alpha minus beta to stand below? So therefore, taking the root of both sides, we have the square root of alpha minus beta all squared to be equal to the square root of alpha plus beta all squared minus 4 alpha beta. Now notice that the square cancels the root for the left hand side, and left over is alpha minus beta, is what we are looking for. That is equal to this. So eventually, by substitution, we have alpha minus beta to be equal to the root of alpha plus beta, that's 4 over 3 squared, then minus alpha beta is negative 1 over 3, so negative 4 multiplied by negative 1 over 3. So simplifying this form, we now have alpha minus beta to be equal to the root of 4 over 3 squared gives us 16 over 9. We have in that sense. Then negative 4 times negative 1 gives us positive 4 over 3. So let's add them up. LCM is 9. So 9 and 16 gives us 16 plus 3 in this is 30 times 4 is 12. So we have the root is still there. 16 plus 12 gives us 28 over 9. So this is our final answer. We can allow the roots to affect the denominator and have alpha minus beta to be equal to the root of 28 over 3. And that is it. If you want, you can simplify this word. But if you are dealing with a multiple choice questions or objective questions, then I recommend you only see your answer in simplest form. It is that 28 is the same as the root of 4 times 7 over 3. Root of 4 is 2. Then final answer in this form for alpha minus beta is simply 2 root 7 over 3 entirely divided by 3. Okay, very well. Regardless of how you write this product, then the 3 is affecting the 2 and 7. And that is the solution to alpha minus beta. And this is how to easily solve for any other relation in terms of alpha and beta using alpha beta and alpha plus beta. I hope you find this helpful and understandable. Feel free to subscribe if you find this helpful. Thanks for watching. See you in the next video. Bye for now. However, this is your exercise, so feel free to share your solution via the comment section below. Using alpha plus beta and alpha beta, find the value of this relation, 1 over alpha plus 1 and plus 1 over beta plus 1. Feel free to share your solution via the comment section below. Bye for now.